By the year 2030, people are expecting something pretty cool, a world where the physical and digital worlds blend together seamlessly. Applications that can exploit this will need smart connectivity technologies to be able to communicate without any lag or interruptions, or it'll ruin the experience, or worse, cause accidents. The REINDEER project is working on a cell-free, massive MIMO approach for such 6G applications, called RadioWeaves. The project partners have defined 13 use cases to better understand the requirements of the future. Let's explore the first cluster of use cases, focusing on future factories, warehouses, and logistics. Think of a production hall. Within a 140-meter by 70-meter area with a height of 15 meters, approximately 20 individuals are likely to be present alongside autonomous robots and unmanned vehicles that may be operating at speeds ranging from 3 to 15 kilometers per hour. The surfaces are expected to be highly reflective, and many blocking elements will be present. Up to 1,000 devices are expected to be present, up to 20 on UVs alone. RadioWeaves antennas and service points will be set up along the walls, ceilings, and support columns, where external power supply is available, with an average distance of 10 meters between each device. This cell-free infrastructure setting provides a reliable connection without blockage, while working at gigahertz frequencies to support high throughput, low latency, and high positioning accuracy for a high number of simultaneous devices, and will support wireless power transfer as well as real-time processing via local edge computing. The use cases for this setting include real-time digital twins in manufacturing. Mirroring the physical factory will help to monitor manufacturing processes in real time, simulate potential changes before implementing them in the physical twin, and add enhanced functionality such as improved control, intrusion detection, and other security features. The bidirectional communication between the digital and physical twins requires extremely high reliability, low latency, and accurate real-time position information. Human and robot co-working. To ensure human worker safety while robots zoom around with high-speed movements and wield dangerous tools, accuracy and reliability are crucial. Low-latency communication is also vital in industrial settings where seconds count. To ensure seamless operations, sensor data and video streams must be processed, requiring coordinated communication between robots and the back end. Tracking of goods and real-time inventory. To stay ahead of the game in today's fast-paced business environment, accurate and real-time inventory tracking is crucial, enables informed decisions on the fly, and avoid costly supply chain disruptions. It will require accurate, real-time localization and identification. Electronic labeling. Energy-neutral electronic labels for dynamic information display and position information, e.g. attached to shelves, will require services like wireless power transfer, communication, and accurate localization. Augmented reality for professional applications. Augmented reality use cases will employ lightweight, energy-efficient AR goggles or contact lenses. Image processing for displays and cameras will need to be offloaded to the edge computing infrastructure, and the device battery must be kept small, so low latency, a high data rate, and wireless power transfer support will be crucial in addition to high accuracy, real-time positioning. Position tracking of robots and unmanned vehicles. Position tracking will be crucial, especially on reconfigurable factory floors, and requires quick updates, low latency, so that equipment locations are always known, and, if needed, control signals can be sent to moving machines in real time.